elements that I have highlighted in blue. So the 7 elements that I have highlighted in blue, ladies and gentlemen, are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And then the note down below is that those are the 7 diatomic molecules, ladies and gentlemen. Those 7 elements will never, ever, ever, never, ever occur alone when you talk about them. What I mean is if you talk about oxygen being created in a reaction, if you talk about hydrogen being a reactant in a reaction, you will write H2, you will write O2, you will write N2, you will write F2, Cl2, Br2, and I2. When they are not in a compound, when they are elemental, they all have 2's by them. They are the only 7 that do that. The only 7 elements that do that. So highlight them and get that note on your periodic table, ladies and gentlemen.
Oh, that was yours? And you gave it to me. Shoot.
All right. So, understand, in this unit, ladies and gentlemen, and in Unit 6 and Unit 7, there are times where it is going to tell you that, for example, copper metal reacts with something. When we write copper metal, we would write just the symbol Cu. Now, when you have something that is in the elemental form, it has no charge. Iron has no charge until it can combine with a nonmetal where it can lose its electrons to that nonmetal. So if you are talking about iron alone, we write the symbol Fe and it has no charge to it at all. Now, on the other side of the reaction, it's probably going to be in a compound. Now we do what we did yesterday, which is we figure out what the charge of the iron is, we figure out what the charge of the nonmetal is, we crisscross, we write a good compound. But alone, any element has no charge. An element cannot gain or lose electrons until it is with another element that it is combining with. So a metal has to be with a nonmetal or a polyatomic anion on the back of your sheet before it can get to become a charged atom. Okay? These 7 can be elemental, but when they are, there is the 2 by them. Okay? They are the only 7. You would never write Fe2. You would never write CO3. Alone it is just CO. Alone it is just Fe. Alone it is just Ca. Alone it is just Na. And they have no charge yet. Now when they get with a compound, they will have a charge. Questions? Okay. Take out the green sheet that I gave you yesterday, ladies and gentlemen. We are going to review 2 more types of compounds today, ladies and gentlemen. We are going to review acids, and we are going to review binary covalent compounds. Okay? Now, does anyone need this periodic table up to copy these 7 down anymore? All lefty then. All right. So, there are 2 kinds of acids, ladies and gentlemen. There are binary acids and there are ternary acids. Tell me what you notice about the names of binary acids. They begin with hydro. Hydro means the acid is binary. every acid that I will give you, the first element in your compound is always what? Hydrogen. The first element is always hydrogen, and hydrogen is acting as a +1 metal. Okay? You are going to combine it with either a lone nonmetal, meaning it's binary, or you are going to combine it with a polyatomic anion, meaning it is ternary. Binary means there are only two elements. The first is hydrogen. You just need to figure out what the second one is. But you do still need to balance off charges. Good news, you will never have to reduce acids. Why? Hydrogen is a +1. That is going to end up by whatever nonmetal or anion you put it with. Now, the charge of the nonmetal or the anion does come down by the hydrogen. And there could be one hydrogen, there could be two hydrogens, there could be three hydrogens, something like that. Okay? But you have to understand that hydro means binary. Means two elements. Okay? The other thing is whenever you write the formula for an acid, what do you have to put after it? AQ. Now, AQ means aqueous. Aqueous means dissolved in water. All acids are aqueous. Not everything that is aqueous is an acid. So aqueous just means dissolved in water. Salt can be dissolved in water. Okay? Sugar can be dissolved in water. It does not make them acids. It makes them soluble. Soluble means they can dissolve. Okay? So, hydrosulfuric acid, ladies and gentlemen. The first element has to be hydrogen. Hydrogen is a +1. Where do you think sulfuric comes from? What element? What? What? Sulfur, thank you. What's the charge of sulfur? Negative what? -2. We are going to do the crisscross method to create the formula. Therefore, it is H2S, and we put AQ after it, ladies and gentlemen. That is the formula, or the way we would do a formula for any binary acid. Any acid that begins with hydro. Questions? Hydroboric. Hydro, again, means binary. It does not mean hydrogen, because then people come over here and go, oh, there's no hydrogen in these acids. Yes, there is hydrogen at the beginning of every acid. Hydro tells you that there are only two elements in that acid, and one of them has to be hydrogen. So for hydroboric acid, again, you are going to begin with hydrogen. By the way, for every one of these acids, you're going to begin with hydrogen. They all begin with hydrogen. Hydroboric. Where do you think boric comes from? What nonmetal? Comes from boron. Now, what would be the charge of boron based on its location on the periodic table? Nope, can't be. -5. Now, I don't think I would ever give you hydroboric acid on a test, on a quiz, on something like that. But we can handle it based on the patterns that we have established. So, the formula, H5B and AQ. Questions? Okay, let's now go to a ternary acid. Ternary acid has to have a polyatomic involved, meaning you are going to have to turn your periodic table over to the back side. By the way, hydroxide can never be in an acid, because what would hydroxide become if you put it with hydrogen? What would the formula for hydroxide and hydrogen put together be? HOH, better known as water. Water is not an acid. Hydrogen hydroxide would make water. It would make H2O, HOH. None of the polyatomics that end in IDE will ever be in acids. None of them. Okay? So therefore, all of our polyatomics end in what? Or ATE unless they lose an oxygen, and then they will end in ITE. Now, to name a ternary acid, it is based on a polyatomic. You may want to put this on the back somewhere, especially if you haven't had the course since the first try. An ic acid, an IC acid, comes from an ATE polyatomic. An ic acid comes from an ATE polyatomic. An OUS acid comes from an ITE polyatomic. So if the polyatomic name ends in ATE, it is going to become an ic acid. If the polyatomic name ends in ITE, it is going to become an OUS acid. So we have nitric acid. The ic is replacing the ATE ending. So you tell me what polyatomic is involved in nitric acid. Nitrate. Nitrate has a formula of NO3 and a charge of -1. So I'm going to write the NO3. I'm going to put a charge of -1. Now, what do you know about a +1 and a -1? They cancel. So you don't technically have to do the crisscross method because all you're crisscrossing is ones. But here's what I want you to understand. You will never put the polyatomic in an acid in parentheses. Why? You're always putting a 1 by it. The charge of hydrogen is never going to change. So therefore, you're always going to be bringing a 1 down by this nonmetal or polyatomic. So you don't have to put anything by it. But depending on the charge of the nonmetal or the polyatomic, that number does end up by your hydrogen. Okay? So, again, no reason to ever put parentheses on a polyatomic in an acid. So our formula becomes HNO3, and we put AQ after it. That is nitric acid. Now, hydronitric acid would have how many elements? Hydronitric acid. Hydro becomes binary again. And that would be an acid between hydrogen and just nitrogen. Okay? So without the hydro, it is very important that we understand that it comes from a polyatomic. Boric acid. Boric would come from what polyatomic on the back of your sheet? Borate. What is the formula and the charge of borate? So again, we're going to do the crisscross method. What number comes down by the H? Big difference between hydroboric and boric acid, correct? Hydroboric, H5B. Boric, H3BO3. Ternary acids are named based on their polyatomic. Now, if this had been nitrous, OUS ending, the only thing that would change is instead of nitrate, it would come from nitrite. It would be HNO2. Now, I don't think I give you a lot of acids that use OUS endings. But understand, any polyatomic that would end in ITE could become an OUS acid. Any polyatomic that ends in ATE becomes an ic acid. And yes, hydro ends in ic acid as well. But you should never, ever, ever wonder if it's an acid when you look at a name because the word acid is in the name, ladies and gentlemen. Questions? Okay. Now, there is one other type of compound that we will have to name. And that, ladies and gentlemen, that, ladies and gentlemen, is a binary covalent compound. Binary means what? Two. Covalent means that they are both non-metals. There is no metal in a covalent compound. Okay? Now, I have told you that 90% of the time you are going to be going from what to what with formulas. No, I'm sorry. I'm not saying this real well, so I'm just going to come out. You are going to be going from a name to a formula. A name to a formula. Okay? So when you look at a binary compound, you will find a prefix in it. You will find one of those prefixes in the name for sure. You will find mono, you will find di, you will find tri. Now, it may not be until the second element, because if the first element, there is only one of them, we never begin a name with mono. So no name begins mono something. Okay? Mono can be the second part of your compound. Carbon monoxide. Mono means one. No prefix at the beginning means there was one of that first element. So carbon monoxide means one carbon, and monoxide means one oxygen. One carbon, one oxygen. Do not do anything with charges. There are no charges in a covalent compound. I could never give you two nonmetals and say write a compound for them because you have no way of knowing how many there are in the compound. Unlike in an ionic where we have to balance off charges, you don't do that in a covalent compound. So covalent compound, I'm going to have to give you the name. Now the way you will recognize the name, ladies and gentlemen, is again, you will find a prefix somewhere in the name. But also, carbon is a nonmetal. The first element is going to be a nonmetal and not a metal. And there will only be two elements there. That is it. Covalent compounds are easy, but people make them difficult. Okay? So let's take a look at a few samples. This is the next slide in the agenda. So, disulfur pentafluoride. Di and penta are your prefixes. Di goes with sulfur. Di means how many? Now, the prefix is before, but it shows up as the number after the symbol. So sulfur is S. Di means that there are two of them, so it is S2. No charges, nothing. S2. Penta means how many? Fluoride means F, fluorine. S2, F5. There is your compound, ladies and gentlemen. That is it. Okay? You write exactly what the name tells you. Trisulfur, meaning S what? S3. Octahydride. Hydride is what? H8 for octa. That is your compound. That is all you have to do. No crisscrossing anything, no putting up any charges. You are writing exactly what the formula is telling you. Hexacarbon decahydride. Somebody. C6H10. Questions? Now, that green sheet that I gave you yesterday, ladies and gentlemen, The bottom two boxes on the front and the back are reviewing covalent compounds and acids. My suggestion, do the back side first. That is the way you will normally be getting these. You will be getting that name and have to write a formula for it. Okay? You'll be getting that name and have to write a formula for it. So that is the part that you will be expected to do 9 times out of 10, maybe even more. So, ladies and gentlemen, you've got 12 minutes. I'll give you 15 to get as much of these finished. Now, I did take and just put the answer keys on a stack in the back. If you want to grab it and look at it, you are welcome to. If you want to call me over, if you have questions, you can ask. But let's get this done, ladies and gentlemen. You have 15 minutes. Let's go. Again, if you want to go move around, you are welcome to, ladies and gentlemen. Yes, Wendy. Keep your phone up on the desk and sign out. Yes. Anybody else have highlighters that they borrowed from me? I'll return. I'll take them back. Thank you. Okay, on your turn.
And we shouldn't drive.
So, that's how we accomplish it. Okay, which makes it carbonite. Oh, what is the acid? What is it? Ice acid become?
We have to first cross.
Ice becomes an OUS acid. So, like here, you took chlorate and made it chloric acid. Here you have carbonite, it would become carbonous acid. It's not supposed, you don't do hydro unless it is binary. These are all wrong.
I know, it's a redo.
Okay, I didn't see that, sorry.
It's good.
So, a name either begins with hydro or it begins with the start of a polyatomic. Yes.
This is correct.
Yes. Well, no. Where'd you get the charge on iodine? It's a 3. It's 3.
Because if it's hydro, it loses 2. Okay?
Whoa.
No?
That is hypo. Hydro is the name of a binary acid.
My bad, gang. Buddy.
And even if you would lose 2, IO3 becomes IO. That's losing 2 oxygens.
Negative.
Please don't argue with me.
Sorry. I'm just.
The rule you're saying, for hypo, is losing 2 oxygens, not charge, just 2 oxygens. So, for example, iodate is IO3.
Mm-hmm.
If it loses 2 oxygens, it becomes hypoiodite, ITE. What's 3 minus 2?
1.
So it would be IO still.
Okay.
And then that would be called hypoiodic or hypoiodite, which could become hypoiodous acid. But that wasn't what you had. Hydro means 2 oxygens.
Yeah, I confused the two. My bad.
I understand, not a problem.
It's binary, it is
No, you're writing an acid. Acids always end in ic acid. Now, if a hydro is in front, that means it's binary. If there's no hydro in front, it means it came from a polyatomic that ended in ATE. So there are actually 2 ways you can end an acid. Ic acid or us acid. Even a binary acid ends ic acid, but it begins with hydro. So hydroboric acid, hydrobromic acid, hydrochloric acid.
So it's hydrochloric acid.
Correct. Yes. A hydro tells you it's binary. All that begin with hydro end with ic acid. Polyatomics on the back of your sheet, if they end in ATE, they become ic acid. If they end in ITE, they become OUS acid.
No,
Okay.
like it made sense at
Good.
the beginning. Luckily for me, I have a good.
Any questions?
Bro, I would never, on my mama, I would never do that.
Yes.
I was doing the work. Yeah, towards the end.
It would be at first.
Listen,
So which one?
that was yesterday. Today's in. Today, I'm not gonna.
I almost done.
So that's 2 that I got.
I have to redo these, but none of them.
I really want that.
No, because this time was the bottom, because last semester, I think.
Jaden, did you find the error yesterday too? Were you the one who pointed out the error yesterday? I thought you were 2 for 2.
Instead, you're only 1 for 2. I'm disappointed. Disappointed.
Only binary was this number.
Next, right.
What was the other one?
Wait, okay. So for this one, we'll do this one. You take away one of the.
Because you said us ends in 8.
That's what I
Not
thought.
8.
I got a little confused and I was like, wait,
Eh.
these change because then it wouldn't make sense when I just told us this. Okay, what can I say again?
Okay, number 4 on the front page is HC to the
What are you talking about?
first page.
Not on the first page. Oh, number 4?
Yes. That's what it says.
Wait, I don't think I did that one.
Does 8 turn to ick?
Yeah.
Does 8?
8 turns to ick.
You guys need to calm down and talk.
Natalie, have you ever been in a class with Anaya before?
Yes,
This is as calm as she gets. Okay.
I know, but it's especially hard when them two are together.
I understand that. We can separate them.
Yes, I have. We had,
I have seats up in the front here waiting for you, Denaya.
No, she likes it back here. I can't.
She has the time today. Well, for me. Okay. I passed. I'm social because I was family. Okay. The answers are in the back.
Yes, they are. Mr. Brown? Yes, I do. Sure. Okay, bye. Kevin, student services. Hold on. Your pass is gone, Kevin. You just gone.
Yes. Arsenic, yes. Yeah.
HAS. H3.
Yeah, here's the thing. Hypo means that arsenic belongs to arsenic is it's still in H3, so it's like H3. Okay. Yes, that is there. There's a couple letters writing down correct. Yeah, I sometimes get remember. All right, let's have a seat, ladies and gentlemen. I'll put the answers on the board for you if you didn't have them. By the way, whenever you are looking at keys in my class, please understand that there are sometimes typos in them. I make the keys. I am a big fan of cutting and pasting. So sometimes you're going to see things and you're going to be like, man, this looks like the last problem. That's because I cut and pasted the last problem and brought it down and didn't finish changing it like I should have. So I rely on you guys when you find an error in my keys to let me know so that I can correct it. Now, if you go through every problem and you're getting every problem wrong and you're like, man, Mr. Brent did every problem wrong on this key. No, I did not. But if you are doing them right and all of a sudden you get to one and you're like, I don't think this is right. This does. Please tell me about it. I will check my key. And most of the time, yes, I made a typo on it. Okay? So, here are the answers, ladies and gentlemen, for the backside formulas. And yes, there is a typo in hypoarsenate or hypoarsenic. By the way, there's still a typo in that. If it has hypo at the beginning, what should it have at the end? Should be an OUS ending. That is my bad. Okay? That is my bad. So that one should be, I gotta find it. Hypoarsenous. OUS acid. You cannot have hypo and an ic ending. Because hypo means that you have lost two. Okay? So I will make those corrections. And I will eventually change this before I put them back out. But since I've got them all printed, I'm not going to change it until we find all the mistakes that I have made on it. Okay? So that should be hypoarsenous, OUS acid. Okay. Any questions on the ones on the top or the ones on the bottom? Anything else you think I have wrong?
Isn't there supposed to be for a hypoarsenous? Isn't there supposed to be a 2 after the oxygen?
For this one?
Yeah.
Should be a 3 because I believe arsenate is a -3 charge. Unless I read it wrong on the back of the sheet.
No, 4 has 4 oxygen.
Okay, I see what you're saying. O2, my bad. As long as I'm making mistakes, I might as well get them all out of the way right away. Correct. Lost 2 oxygens, became ASO2. Thank you very much, Natalie. Well, it's just that one that I messed up completely, so I guess we're doing okay there. Other things. You think?
For boric acid, H3BO3, some.
Yep, should be BO.
A 2 after the O.
Yes, a 2 after the O there as well. BO2 this should be. BO2 because it came from borite, ITE ending, which is borate that has lost 1 oxygen. Now I know I've never done a review for the 3rd try before. So, what Jesus was saying, borate would be BO3. But OUS ending comes from borite. That is BO2. Losing one oxygen. Very good. Any others? All right. Put that sheet away. Take out your computer, ladies and gentlemen. Open it up and get into Canvas and get into the modules for today and find the mass versus amount lab in Canvas. So we are going to do a little activity today, ladies and gentlemen, that ties into what we were talking about yesterday. Yesterday we started talking about the mole. The mole represents an amount of something. And in today's world, ladies and gentlemen, we sell things in a lot of different ways. Yes. Should be. Refresh and check again. Okay. Point is, we sell things in a lot of different ways, ladies and gentlemen. Some things we sell by the amount of them. Perfect example, golf balls. Golf balls, they sell it by the individual golf balls. They sell 3-packs. They sell them by the dozen. They are selling you the golf balls by the amount of golf balls in something. We also sell a lot of things by weight or mass. So you go to the deli at Festival, at Pick and Save, wherever, and you get a pound of ham. You get a pound of cheese. You get a pound of whatever you want from the deli. They're selling you that substance by the mass. Now, again, in the United States, we don't use mass. We use weight. Pounds, we're weird, yes, I know. But mass and amount are two ways that they sell you things by. Okay? That is what we are going to explore in today's lab. Now, the important thing in today's lab, ladies and gentlemen, is you have to get all of your data collected and all of your observations made. If you don't quite get the lab finished, we can give you a little time tomorrow. Also, you are going to probably need a calculator today, so when you go into the lab, you can grab one. So, here's what is going to happen in the lab. You can all get at the lab now, correct? Yes? Okay. So, you are going to make 3 qualitative observations. Qualitative, what you see, what you feel, what you smell. Don't taste anything. Okay? And nothing is going to be talking to you. If the paper clips are talking to you, let me know. I'll get you the help you need. Okay? So, there is a spot for 4 observations. You need to fill in at least 3 of these. You can make more than one observation of what you see. You can make more than one observation of what you feel. I don't know how you can make more than one observation of what you smell. Either you smell an odor or you do not. Okay? So, you're going to go to a station. Right behind Natalie are paper clips. There are marbles. Then at the back station there are nuts. Over there are thumbtacks, there are washers, and there are nails on this side. Those are the 6 things you have to go to. Now, when you get there, there is a tray with loose pieces, and there is a bag that is sealed up with a certain amount of them in it. Okay? You will make observations of the loose pieces because you can feel those. You can smell those, things like that. Then you're going to count out 50 samples. And you are going to find the mass of 50 of those samples just those samples, not the weighing boat that you are going to put them in. So up here you are going to make all your qualitative observations. Then you are going to find the mass of 50 paper clips, and you are going to get me just the mass of 50 paper clips. Now, the easiest way for you to do this, ladies and gentlemen, is there are multiple weighing boats on the top of this station. Count out 50 into one of them. Take another one, put it on the balance, and hit the 0 tare button so that with that weighing boat on there, it is 0.000. Do not assume every weighing boat has the same mass. They do not. But now that you've got your 50 samples and you've got this zeroed out, you take your samples, transfer them, don't lose any, put it back on the balance, and now you will get the mass of just the 50 alone. Okay? That's what you put in there. Mass of 50. Just the 50. Okay? Now go down a little bit further in your lab. There is a bigger table further down, just below that. In that bigger table, you are going to find the mass of this bag of a certain amount of paper clips. So you take this, you put it on your balance. You need to make sure when it is on your balance, it is not touching the sides, it is not touching anything else. If you have to leave the doors open because it is too big, leave them open. Otherwise, shut them and get the mass of this bag of sample. Put it at the top in that table. Right below it is the mass of the bag. I already massed it before I ever put the samples in there. So now you will be able to figure out the mass of that sample alone. And I will show you how to do those calculations. But this is what you need to get done at every lab station. Your observations, the mass of 50 samples, and the mass of the bag of samples. Now, you have got just under 20 minutes to get done, ladies and gentlemen, so you do not have time to waste. Every station, 2 people can be working at it, 2 groups, except for this one. There are not enough marbles here for 2 groups to do 50 at each time. There are not more than 70 marbles in that tray. So only 1 group can work here. Let's go. Get to work, ladies and gentlemen. You need to work quickly to get done. When you're done, you can reset your balances so that the next group can start up with it being 0.0. Sorry, here you go. You're welcome. Okay, so here's what you can do. Do the lab with James. I will take her information and we'll put it into your lab. Okay? And then you can go after class and see if the librarian can get your computer working. Fair enough? But I don't want you to miss the opportunity to do this. Hey, groups of 2. There are exactly 22 people in here. Groups of 2. Find a partner. Find a partner. Adelaide, find a partner. Linda, find a partner. Alicio, who's making it back here, is going to find a partner. There you go. Alicio, I'm going to put you with Claire, okay? Is that all right? Claire, can you work with Alicio? Claire, can you slide in because he's got a bad leg and I want to keep him near the outside here. Thank you very much. All right, good. Work together, you 2. Together. Together. Because otherwise we're going to be at a crunch for stations later on. Okay, what was the one station I said we couldn't have 2 groups at? You guys can get your observations, that's fine, but if they're not done, you're going to end up waiting. Okay? Do not worry about doing the math. Get your information collected, which is your observations, your mass of the 50 samples, and your mass of that bag of samples. Put it on there. You hit the O/T button. Now, if you make sure one touching anything when you do. Start counting off 50 and putting it in there. and if one of you comes faster than the other, so be it. When you have that 50 in there, then transfer it into there to get their mass. Okay, which one did you put on there? Okay, good. So, you guys start counting on 50, you start counting on 50. When you go to use this, that tray is 0 for you. So you can put your sample into there, put it on there, and get its mass. Okay? Insert it back into there when you're done. Okay. Do not drop a digit on your balance. If the last digit is a 0, you write that down. Okay, once you got your mass, get it off there so they can do theirs. And then you'll go and remember to re-zero it before you do the bag of sample. The bag, it needs to read 0.00 before you put the bag on there. Did you guys get that? It needs to be zeroed before you put the bag back on there. So when you go to put the bag on there, after this, make sure this is 0. Put the bag on there and get its mass. Okay? Now, right now, let's move this because this is level. When you do the bag, make sure that's 0 before you put the bag back on. Okay? Alright. So, make sure this is 0 before you put the bag on. So you get their mass. You can include the bag in there. No, you put that for the mass of the 50. No, sorry. Down there. That's the table where you put the bag. Go down a little bit. Up there is where you put the mass of the bag. Okay? We'll figure that out tomorrow. We're going to need to get this done, so you're not going to have time to do your calculations today. Okay? That station has an opening in it. That one back there, I believe, has an opening in it. Unless that group takes it, so right over here, so you guys can go right to that one. I got your computer. Oh. There you go. Now you're ready to rock and roll. Again, don't worry about doing all your calculations. You will never get done collecting your information if you're worried about doing your calculation. Get the mass of the 50, get the mass of the bag, get your observations made. Those are the 3 things you have got to get done today. Put your samples back in the big tray when you're done. Yep, there's a station there. The marble station is open. As soon as someone is done, go to it because we got to keep this station moving. This is the one that everybody needs to get to. If someone's there working, you can still make the observations, waiting for them to finish up with the marbles. Yes. That's your big thing? Good. Warm in there, get the mass. Good. 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 Now you guys are cooking. Now you're cooking with gas. Flip that over. I think it's laying, or do that. Be sure it's not laying. information there. Nails are open. You haven't done nails. Nails are open. It looks like the washers are opening here. How about the one that says 0? Z-E-R-O. Sorry, some of them are a little bit different than others. Okay? Normally it's O/T, but some of them it has 0 on it. Okay?
Oh.
Nuts are open over here too. Half the marbles are open. Thank you, Claire.
Sorry.
Okay, what do you guys think? There you go, look at that. It's like they heard you and they got out of your way.
Maddie, is this 50? Huh? Yeah.
It's 43. It's going down. It's going down.
What do you guys think? Go ahead and start making your observations of your marbles. We should probably be done with that mass by that time. You guys can go right into your mass. There's gonna be a bag of the marbles. Are you guys done with them? As soon as one group moves out, go ahead and start making your observations. We're getting their masses and things. You put them on a pole and you make sure that the nut does not work its way through. Right? They get attached to a bolt. On the other end of the bolt, you put a nut. Those make sure that the nut does not work its way free on a machine that will move around the lot. What do you guys have to do? Still on. Now, did you guys make any observations when you were at these stations?
Oh. Yeah.
Put down the calculator, go back and make your observations. Hurry up, because the stuff is going to be gone tomorrow.
Observations, mass of the 50, mass of the bag. That's what you need to get done. Colors, how things feel, how they smell. When you touch something, is it smooth? Is it slippery? Is it sticky? Is it rough? If you are to the point, ladies and gentlemen, where your observations are made, for the table where you are supposed to find, where you found the mass of 50, you are going to take the mass of the 50 and divide it by 50 to get the average mass of one of the sample. So your mass here divided by 50 will give you the average mass of one of those. That is the number that you are going to need. Well, sig figs, right? Okay? So, your mass of 50 has a number of sig figs in it. 50 cannot limit your sig figs. Okay? For your average mass, let's go 3 places beyond the decimal at least, unless the first place beyond the decimal is a 0. Then go 4. So if something is a mass of over 1 or over 0.1, go 3 places beyond the decimal. Okay? 3 places beyond the decimal.
Do we have to round?
Well, you would round after the 3 places beyond the decimal. So if you have 0.8762, you're going to round it to 6. That's the 3rd place. The 2 after says just leave it. 1.056. What's the number after the 6? Then you would leave that as a 6 because the 4 says leave that number.
Then change the Oh,
You just leave it. You're going to go 3 places beyond the decimal.
you okay?
I'm sorry, what?
Are you okay?
Yeah, I was just going to get something and I got distracted and I forgot what I was going to get. So whatever it is, it'll come back to me later. Madison, get your son. Oh, not a problem. There you go, sir. All right, see you tomorrow. Thank you. I gotta go.
Is Anna here?
I have no clue.
Do it. Mr. Brad, what hour do you have Anna?
Good question.
She didn't tell me what hour she is.
Well, maybe that's because she doesn't want you to know.
I guess so. We need to know these things.
Why?
Because we're nosy people.
I understand that.
Do you? Truly? I think she maybe told me that. Exactly. That's on her then, because like, why would she tell you? Like, not
Let's put it this way. I see her before she goes home.
Oh, so put that way.
I didn't say that.
Okay. Yeah, but you implied it.
I didn't imply anything.
Lies. I don't know if she's here or not. She better be here.
Yeah, she better be here.
Thank you. You should pay her if she isn't here.
I remember what I was doing.
I remember.
I was just counting.
I don't. Wait, what the?
Student left this with me in the first try. I'm going to give it to the 3rd try teacher so they can give it back to them.
Oh. Okay.
No, ka, not an O. Wow. All right. Tomorrow when you come in, open up the lab right away. We will begin on the calculations. Again, you are going to take this mass divided by 50 and get an average. That average is then going to go into the table down below. Average mass of 1 piece of sample. You're going to take the mass that you got here minus the mass of the bag to get just the mass of the sample. You will then divide it by the mass of one of them to figure out how many were in the bag. Now this number down here has to be what kind of a number, ladies and gentlemen? Good, a number. How about a whole number? Because there were no half of nails. There wasn't a quarter of a marble. So this number down here, you're going to be rounding to a whole number. You're going to calculate how many pieces of each thing were in the bag. So that is what you come in tomorrow. You grab a calculator, you get with your partner, and you get started on that. Have a great day, ladies and gentlemen. We will see you tomorrow. Goodbye, goodbye, goodbye.